Hello everyone, this is Dr. Muhammad Chat. I'll be your instructor for the MEC 300 Material Science. As we discussed before, through this course, we are going to discuss different aspects related to the materials, material science, and materials engineering. We're going to discuss the different types of materials and how we can do the classification of material based on their chemistry, based on their structure. And the main objective of this course is to show you the relation between the material structure and their different properties. So it is very interesting subject and you're gonna enjoy it. I'm pretty sure of that. And in this video, we're gonna start chapter 1. Chapter 1, this is the introduction about the course. We are going to demonstrate some keywords, some concepts related to the materials engineering. These concepts are very important to understand them because we're gonna use them through the course. So it is very important to follow in this introduction. And this chapter 1, this will be covered over 2 videos. This is the first video, and in the second video, we shall be ending of the chapter 1, right? So as we mentioned before, this is the textbook that we're gonna consider, which is Collister's textbook of material science and engineering. This is very common textbook, very famous. You could say that all universities, many of the universities and mechanical engineering program there are using and following this textbook. So it is very interesting. This is very fundamental textbook. So that's why I highly recommend that you have a copy of this textbook. So as I mentioned, this is the introduction of this class. In this introduction, we are going to demonstrate these different learning outcomes, starting with the difference, showing you the difference between material science and materials engineering. These are like kind of 2 different concepts of treating and dealing with the materials, like how we gonna consider the material. So these are not difference in terms of material, but they are different points of view, how we are going to see how we are going to use this material or consider the material. So these are 2 different points of view of materials. So this is one of the objectives of this chapter, is just to show you the difference between material science and materials engineering. Material science is going to be the main objective and the main concern of this subject, since the title, this is intuitively because the title it is material science. But materials engineering, we're going to consider this in another course, especially for mechanical engineer, which is the manufacturing processes class. For example, we're going to discuss the materials again, but from the engineering point of view, not from the science point of view. So again, this like 2 different points of view. It is important to start discussing the difference between this material science and materials engineering. Then also we're going to discuss the different components of the general discipline of material science. These disciplines of the material science, like different subjects, or in order to study material science, what are the things that you have to study? Or in order to be classified as material scientist or have a background in material science, what are the things that you should consider, or what are the background that you should have to say that you have a background in material science? These are also these disciplines. We're going to introduce them through this video. Also, we're going to discuss some new keywords of material science. Again, these keywords are very important to understand them because we're going to use them a lot through this course. Also, we're gonna know the different forms of material structures. And this is very important. As I said, the main concern of this course is to connect the material structure to the material properties. So it is important to know what are the different forms and different types of the material structure. Also, this is one of the points that we're gonna cover through this video. Also, the classification of materials based on their chemistry, and more importantly, based on their structures. There are actually, in fact, there are different ways of doing classification or providing a classification of materials. We can do the classification based on the material properties, based on their chemistry, based on their structure, based on their, applicability of the material, how we are the application of the material, which would be related more to the engineering side. So there is engineering, there is engineering classification of the material, and there is material science classification of the material that mainly gonna depend on the material structure. So we're gonna try to discuss these different classification of the material, especially the chemistry classification and the based on their structures. Also, we're gonna compare between the different types of material based on their properties. The property of the material, this is what distinguish one material from another one. And these properties, this is also one of the things that we are going to discuss. Also, we're going to know or introduce some of the newly developed advanced materials and nanomaterials. Nanomaterials, or generally metamaterials, these are different types, and there are more actually. These are newly developed materials that we basically develop these days with more enhanced properties over the conventional material or the natural material that we basically knew. So it is highly important actually, although this topic, it is not fully covered in the textbook, or you could say that it is not covered, I mean the advanced materials and nanomaterial, but it is, these days it is highly important to know these different types of advanced materials and nanomaterial, because we already developing them, and even we started the application phase of this material, that now we can involve these nanomaterials and advanced material in different applications. If we're going to talk about your cell phone, any other things that you are using every day, these devices, these systems, for sure they already incorporating some of these advanced materials. So it is highly important to discuss this subject also as a part of this chapter 1. Make sense? So let us start with the first learning outcome, which is the difference between material science and materials engineering. So what is material science? As a definition, material science, it involves investigating the relationship between the structure and the properties of the material. So what does it mean this? It means that very simple, like if you could able to find a relation between the material structure and how this material structure would affect the properties of the material, this is material science. The main objective of a material scientist is to find this relation. If we understood this relation or find this relation, we can even develop new materials. This is also one of the concerns of the material science. So simply, material science is to study the relation between the material structure and the material properties. So what does it mean, material structure? This is structure, it is a key word that should be understood. We have to understand what does it mean, material structure. Properties or material property, also this is another keyword. What does it mean, material property? These keywords will be discussed through this video as well, right? So, but very quick, what does it mean, material structure? Material structure, this is the composition, the thing, how we are going to form this material. One of the simplest way that you could understand what does it mean, material structure, is that you consider the atomic structure of any material. Like any material, if we're going to talk about material, the thing that you are using every day, your desk, your pen, your skin, anything that you is something that we can touch, this is a material. This material, it has a structure. This material, whatever it is, any material, it has a certain structure. And this structure, in many cases, it is different from one material to the other one. And because of this structure, the properties of this material will be different than the other one. Make sense? So the structure, for example, one of the things, if we're going to consider a metallic material, metal, like an aluminum, steel, copper, whatever the type of the material. If we're going to look inside this material through a microscope in many cases, you're going to see that this material, it is composed of set of atoms. One atom, and that is connected to another atom, and so on. So this atomic structure, so this is the atomic structure of the material. What does it mean? It means that these atoms, they are arranged in a certain way, in a certain manner, to form a structure, to form the material. So we could say that the material itself, it is just a structure. How we can find a relation? If we could able to find a relation between this arrangement of the atoms inside the material and the properties, this is material science. So what does it mean this? It means that if we change it, if we do changes to the atomic structure of the material, definitely the properties of the material is going to change. So how we can change the material structure to end up or to achieve certain properties, this is also require material science. We should have a relation between the structure of the material and its properties, its characteristics, its behavior, kind of. So this is the main concern of the material science. So simply, One statement. What does it mean, material science? It is just finding a relation between material structure and material properties. So as I mentioned, most of the properties of materials are related to their structures. Thus, the concern of material science is to study the structures of materials and relating them to their properties and hence their application. If we could find a relation between the material structure and its properties, we can simply recommend certain material for a certain application. So we can use this material. But if this information is not given, or we have no clue about this information, we have no clue about the relation between the material structure and properties, definitely we won't gonna able to use this material. So the material science, it is a very important field that many of the mechanical engineers, civil engineer, electrical engineer depend on. And if you remember from the introduction to mechanical engineering course, is that one of the essential requirements for you to be mechanical engineer that you should have some knowledge on material science. Why? Because you're gonna use this material for different applications, so you should have this knowledge, and that's why you're studying this course as material science. Make sense? How about materials engineering? Material engineering, as a definition, it involves designing or engineering the structure of a material. So again, we are talking about the material structure, how we are going to design this material structure to produce a material with predetermined set of properties. Like the objective of materials engineering is to produce a material, is to manufacture a material, is to process a material. Producing this material based on a knowledge of material science, that you should have first some knowledge on material science. Based on that knowledge, you can build, you can propose a technology, you can propose an engineering method of tailoring, of changing or engineering the structure of the material to achieve certain properties. This is materials engineering and some of the objectives or functions of the materials engineer. Materials engineering depends on the structure property correlation or relation. Like we should have knowledge first on the relation between the material structure and its properties through the material science. It means that you should have some background on materials science, which are the concern of the material science. Thus, we can summarize that the role of a material scientist is to develop and synthesize new materials, to produce new material. This is one of the things. That one of the essential things of a material science is to find the relation between the structure of a newly developed material. He is going to develop, produce, create, invent new material. This is material scientist. And in the meanwhile, he should provide the relation between the material structure and its properties. I develop new material. This is brand new material, right? But you have to provide in the meanwhile what is the relation between this material structure and its properties. This is also one of the things that material scientists should do. Based on this outcome that the material scientist provided us, a materials engineer can use this information to produce new products, new systems, new mechanical system, electrical system, civil engineering applications. We're gonna use this material for a certain application based on the outcomes of the materials science and to develop techniques of processing this material. So we knew the relation between the material structure and properties. We already have this material, so we can provide or create or invent new technologies to process this material for different application. This is the materials concept or the engineering concept of material engineering. Make sense? So this is very quick, the difference between material science and material engineering. And again, the objective of this course is to study materials science. As for mechanical engineers, materials engineering part or the materials engineering concept will be considered in another course, which is the manufacturing processes class, because here we are talking about the manufacturing of the material. So we're gonna consider the engineering point of view of the same material that we are going to cover through this course. But this course, through the material science course, we're gonna focus on the science of these materials. Make sense? Now let us move to the components of the discipline of material science, or the different subjects or essential keywords of a material science. Or in other words, in order to study material science, what are the subjects that you should cover in a material science course? It is not necessary to cover all of them, but anyway, you should have background on on all of these different disciplines of the material science. So starting with there are actually 4 disciplines. We do have the processing, the structure, the properties, and the performance. So we're gonna say that we do have material processing. So you should understand what does it mean material processing. You should understand what does it mean material structure. You should understand what does it mean material properties, material performance. So the difference between these different 4 keywords or discipline or subject of material science, you should understand them, and this is what we are going to discuss, starting with the material processing. So what does it mean material processing? It is simply to develop and synthesize or to produce a material with a certain structure and properties. All the time the structure is related to the material properties, as I mentioned. So material processing, simply processing, it means is to produce, is to manufacture, is to develop, is to synthesize a new material or an existing material with a certain structure and properties. This is the meaning of material processing, just to produce the material. This is material processing. So, but what about the material properties? I'm gonna skip talking about the material structure because the material structure, it is a very important subject and we do have different types of the structure. So I'm gonna skip this one for now and let us move to the material properties. What does it mean a material property? A material property is a material trait. This is like an inherited trait of this material in terms of the kind and the magnitude of response to a specific imposed stimulus. So what does it mean, all of these things? Let us start first. What does it mean stimulus or stimuli? So stimulus actually, it is anything, something that excites the material to do something. So the stimulus is anything that is going to enforce the material to do something. Like for example, if we're gonna take this example of a human being, you as a guy, if somebody pushed you, so the pushing, it is a stimulus to you. Based on the push that you're gonna get, you're gonna react. So there is action and there is a reaction. Your reaction to this push will be dependent on your character, dependent on your specification as human being. Are you a nerve guy or a very calm guy? So if you are a very nerve guy and somebody pushed you, you probably for some reason your reaction is gonna be you're gonna punch him in the face, right? So this basically depends on your characteristics, depends on your properties. So there is a stimulus, there is an action, there is a push that enforces you to do something, to do a reaction. So the action, this is the stimulus. So impose the stimuli. If we're going to talk about material science, the stimulus, it would be in chemistry, for example, the stimulus would be chemical agent, which will like motivate for chemical reactions, or it would be heat, it would be light, anything. This is in terms of chemistry. In terms of mechanical engineering, for example, the stimulus would be a mechanical force, would be electrical force, magnetic force, thermal force, or thermal load. So like, for example, you do have a material and you're gonna push the material with a force. So this material is going to deform. So the deformation of the material, this is the material performance. Like you have a material and you're gonna push the material with a force. This material, it would move or it would deform. So the movement of the material, because of an external stimulus, of an external force, this is the performance. How fast this ball or this material is going to move. If you push the material, this is the performance of the material. If you measure the velocity, the acceleration of movement, this is the performance. How the material is going to react for a given action. This is the performance. So we do have action, we do have reaction. There should be something in the middle. This something in the middle is the material property. That the reaction of the material for a certain action, definitely it do depend on the material properties. So this is the physical meaning. What does it mean, a material property? So a material property is it is a material trait. Trait, it means something that is going to distinguish one material from the other one. So we can do classification even on the material based on their properties. Like this material has certain specification, this material has different specification, so these are two different materials. So what distinguishes one material from the other one is a material property. So the material property, it is a material trait in terms of kind, in terms of magnitude of response, how the material is going to respond to an external force, to an external heat, to an external stimulus in general, to an external action. This is the physical meaning of a property. Make sense? There is a statement that had been mentioned in the textbook, which is correct in many cases, but now with the new technology that we are developing, this statement requires some, like to be more accurate, right? So like, for example, it is mentioned that the definition of properties are made independent of material shape and size. So what does it mean this? It means that the material property, it should be independent, doesn't depend on the material shape or the material size. So for example, no matter what the material is, the shape of the material or the size of the material, this material property will be the same. Like for example, if you have a metal with a certain property like the density, this is a physical property. Like for example, the density of metallic part. The density doesn't depend on the shape or the size. No matter what the size of this part, it is huge or small, no matter what the shape is, it's circular, spherical shape, it doesn't depend, this property doesn't depend on the shape or the size of this material. And this makes sense. Many of the material, you could say that all the material that we are using as engineers, their properties don't depend on the shape or the size of the material, right? But now we can develop some advanced material. Here I'm talking about the advanced material. We can develop some advanced material that their properties would depend on the shape or the size of the material. So this gives a new aspect of engineering more advanced material with more enhanced properties that do depend on the shape and the size of the material. So to be more accurate, we could say that whereas properties of materials are generally independent of shape and size, advanced materials such as metamaterials and nanomaterials would exhibit or provide properties which are size and shape dependent. So this is going to be more accurate, and this is actually based on new studies. One of these new studies is my study in Mechanics of Material published in 2019, that in this study I've demonstrated that generally speaking, most of nano-sized material, their properties are size dependent. What does it mean? It means that if we decrease the size of the material to the nanoscale, the material property will not be constant anymore, and instead it's going to be dependent on the size, and in many cases it's going to be dependent on the shape. So the more accurate statement, it should be said in this way, like whereas the properties of the material are in general independent of the shape or the size, we can develop some advanced material like metamaterials and nanomaterial whose properties would depend on the size or the shape of the material. And this is one of the new achievements in the field of material science these days. Make sense? So we so far have discussed two disciplines, which are the properties, the material processing is just to produce or manufacturing a material, the material property, which is a trait of the material which distinguish one material from the other, that distinguish the response of the material to an external stimulus. Like depending on the properties of the material, this material is going to react for a given action. Make sense? Also, now let us move to the material structure, but before that, let us discuss very quick the performance. As I mentioned, the performance, it is the response of the material to the external action. Like is how the material is going to act in different applications. Like if we're gonna use this material in a certain application, definitely when we involve this material in a machine, it's going to be subject to some forces, like torque force, like bending forces, like some heat, right? So all of these are different stimuli, different actions, and this material is going to perform, is going to react, is going to respond to these actions in a certain way. This is the physical meaning of material performance. So simply material performance is how the material is going to act in different application, or is going to react. The material performance can be investigated by measuring its response to different stimuli. Like you're gonna subject the material into a force and measure the deformation or measure the movement of the material. If it is free to move, this is known as the material performance. What basically the material performance subject, it is covered in a different course, not in the material science course. Why? Like for example, if we're going to talk about mechanical engineering, it covers in the mechanics of materials course. In mechanics of material, you study, your main concern actually is just to study the performance of the material with certain properties to an external action, to input force, for example. So this is the concern of the mechanics of material. So basically the performance of the material, it is usually covered in a separate subject. The same thing for material processing. It is usually covered in another subject, which would be related to the manufacturing technologies or related to the different manufacturing technologies for making new material, whatever. Because for example, material processing, we could use chemical methods, we could use mechanical methods. I'm going to try through this course to give you these different methods, especially through the project. So one of the things, and this is going to be clear when we discuss the project, like your objective is just to produce a material. This material you're gonna use for producing this material or for processing this material, you should use either a chemical method or a mechanical method to produce this material. This is gonna be the objective, one of the objectives of your project for this course. Make sense? It means that this actually, the material processing, it should be like a separate subject, and in many cases it is covered in separate courses. So that's why the main concern and the main focus of the material science course is going to be over these two blocks, or over these two blocks, the structure and how the structure would impact or affect the properties of the material. Make sense? So we have discussed these three disciplines. We still need to discuss the structure. What does it mean, material structure? So material structure simply, it is the main building units or the different building units of the material. How you're gonna see the material. So materials have different levels of structure. We may have macrostructure of the material, we do have microstructure of the material, we do have the nanostructure of the material, we do have the atomic structure of the material. So simply the structure of the material, how you are going to see the material. As I said, material is something that is touchable, like you should touch this material, right? So starting with the microstructure, which makes sense. Simply the macrostructure is the apparent structure of the material as seen by the naked eye. How you are going to see this material. Like you do have a material with a certain shape. So simply, this is the way that you see the material. This is the macroscopic structure of the material, or macrostructure. It is generally, it comes in the millimeter scale to the meter scale. Like for example, you're gonna have like 1 millimeter times 1 millimeter box of a material, like a small box of a material, or it would be centimeter times centimeter, or it would be in meter box, right? Like a huge sized metallic part. So this is the macroscopic structure of the material. So when we see any material from the macroscopic scale, it seems like a blank thing, right? Like the same thing, like a surface, like a blank thing. It won't gonna be seen in this way. This figure here, it is a typical example of a material microstructure. So this is another level of the material. Remember that the level of the macrostructure, it is in millimeters, in meters, in centimeters, and so on. But the microstructure, the material is seen to be composed of repeated microscopic unit blocks. Very tiny things that you aren't gonna able to see them by the naked eye. You have to look at it through the microscope. And remember, this bar here in this figure is known as the scale bar. This scale bar, it is 20 micrometer. It means that the length of this horizontal dash, if you measure this one, this is equivalent to 20 micrometer. 20 micrometer, it is 10 to the negative to the power negative 6. 10 to the power negative 6. So what does it mean? It is very tiny, very small thing that you impossible to see this small grain. All of these are different grain. As you can see, like for example, this line, and there is another line here, and this, the thing that I highlighted here, this is just one single grain inside this material. The size of this grain, it is in micrometer. So that's why you will not be able to see this microstructure unless you look at it through a microscope. So the microscope gonna zoom in so you can see the microstructure. In many cases, we are using laser technology so we can detect this contrast in the material microstructure, so we can detect these grains. So the microstructure is that the material will be seen as a composition of repeated, so many of them. One grain, there is another grain, another grain. So like this one, this is another grain. And this small thing is another grain. This small thing is another grain. So you do have lots of grains inside this material structure, right? So this material, it is composed of repeated microscopic unit blocks. These unit blocks, every one of these grain is like a unit. This is the main building unit. The main unit based on which this material is going to be composed, such as crystals or grains. These are if we're going to talk about polycrystalline material, the grains are the main building unit of a polycrystalline material. Most of the material properties are related to its microstructure. Examples like the strength of the material, the toughness, the ductility, the hardness, and the wear resistance. Remember, like the main objective is to connect or to find a relation or to understand the relation between the material structures and its properties like strength, toughness, ductility, hardness, wear resistance. So these are different mechanical properties of the material that definitely we are going to discuss them with more detail in chapter 6 of this course. So I won't gonna go over what does it mean strength, what does it mean toughness, ductility. I won't gonna discuss these keywords now because anyway we're gonna cover them as I mentioned, but these are different mechanical properties and they do strongly depend on this microstructure. Depend on the material microstructure. So the material microstructure is the composition of repeated microscopic, the kind that they should be in the microscopic scale, unit blocks such as grains and crystals, and most of the mechanical properties of the material, they are related to this microstructure like the strength, the toughness, ductility, hardness, and wear resistance. A material microstructure is featured with many defects known as the microstructural defects of the material. These defects, for example, like the grain boundaries. Grain boundaries which are like, for example, what distinguishes this grain from the next grain is a boundary. So there should be a boundary that distinguishes this grain from other grains. The grain boundary is one of the types of the material defects: interstitial atoms, vacancies, twin crystals, substitutional atoms. All of these are different forms and there are more. As defects or irregularities inside the material microstructure, these defects, they do affect the mechanical properties and other properties of the material. So that's why through chapter 4, as I remember the chapter number, chapter 4 and 5, I think chapter 3, 4, yeah, 3 and 4, we are going to discuss how these defects are going to impact the mechanical properties of the material, or in other words, how the mechanical properties or the properties of material would be affected by the defects inside the material microstructure. This is also one of the main objectives and main learning outcomes of this subject. Make sense? So now we do have the microstructure. This is how we are going to see the material. We do have a microstructure, which is the composition of the material internally. We won't gonna see the microstructure by the naked eye. We have to look at it through a microscope. The microstructure, it consists of many building units in the micro scale. Micro scale is gonna be like 10 micrometer, 20 micrometer, 50, 100 micrometer even, but they won't gonna reach to be in millimeter scale or in meter scale. This microscopic building unit like grains, they do impact many of the mechanical properties of the material. Most of the mechanical properties of material are related to the material microstructure like strength, toughness, ductility, hardness, and more. And these properties, they do depend also on defects. There is a defect level at the microstructure. These defects like grain boundaries, interstitial atoms, vacancies, they do impact the material properties. This is also one of the things that we are going to discuss through this course. Make sense? So in addition to the macrostructure and the microstructure, we do have another level, which is nanostructure. Nanostructure, this is actually a new level, and we do have, in addition to the nanostructure, the atomic structure. The nanostructure, it is what we are considering these days to produce nanomaterial. If we're going to talk about nanomaterial, most of the properties of the nanomaterial, they are dependent on their nanostructure, not microstructure. So the conventional material that we daily use, most of their properties, they depend on their microstructure, and this material, they do have only microstructure. In many cases, they don't have a nanostructure. But we found these days, or based on our understanding of material science, based on our understanding of the relation between the material structure and the material properties, we found that if we could able to refine, to squeeze, to decrease the size of the material microstructure to be into nanoscale, to be decreased more to the nano size, we found that we are enhancing the material properties. We are achieving new properties that we never experienced before in the conventional materials. Like, for example, we found that if we squeeze, if we refine this grain, for example, it would be like, if you just measure, this is 20 micrometer, so this side is going to be like around 20 micrometer. We found that if we refined or decrease the size of this grain, like all of these grains, all of them, they're going to be in the nano size. This material will be more stronger, more tough, more brittle, and it means that we are achieving certain changes, significant changes in the mechanical properties. And this is the objective of the nanostructure. But remember, you should understand that the conventional form of the material, it comes with a microstructure only. In many of the cases, this material doesn't have a nanostructure. But we found that by engineering technologies, we can define the microstructure to make this structure to be nanostructure. We're gonna end up with new properties which much way better than the properties of the conventional material with a microstructure. So you could say that the nanostructure, it is originally it was microstructure, but we did something to decrease the size of the microstructure to the nanoscale. So the nanostructure, a material nanostructure refers to objects and the structure that are in the size between 1 nanometer to 100 nanometer size form the material structure. In various materials, atoms or molecules may agglomerate together to form objects at the nanoscale, but these objects in the conventional material, for example, if you do have a material with microstructure, definitely there are some nanostructure, there are some atoms and molecules that agglomerate or collected together or contaminate together to form a nanostructure, but this nanostructure is very small in comparison to the other microstructure. Because the difference between the micro and the nano is 10 to the power negative 9. Nanometer, the nanometer, it is 10, the nanometer, it is 10 to the power negative 9. But the micrometer, it is 10 to the power negative 6, right? So the nanometer is very tiny thing, very small thing. It will not affect the material as long as there is a microstructure. So if there is a microstructure, the effect of the nano things will be very negligible, right? But if we did refine to all the microstructure, to be all of it nanostructure, this material properties will be enhanced a lot. And this is the basic idea of the nanomaterial that we currently develop. So one of the forms of the nanomaterial that we can define the material, this type of nanomaterial is known as nanocrystalline material. This is also one of the types of the nanomaterial that we are going to discuss. In various materials, atoms or molecules, as I said, agglomerate together to form nanoscale sizes, nanoscale objects. These objects can be nanograins, nanocrystal, or nano-inhomogeneities or impurities inside the material, including nanoparticles, nanoporosities, whatever it is. So all of these nanostructures, these are nano things. This is also one of the structure of the material. The material nanostructure influence some of the electrical, magnetic, optical, and mechanical, some of the mechanical properties of the material. So that's why also it is important to know the relation between the nanostructure of the material and the mechanical, electrical, magnetic, and optical properties of the material. These figures here, or these images, these are coming from TEM, which is transmission electron microscope. These are TEM images of different types and different forms of the material. So for example, if we can see the scale here, it is not shown. So I'll just move this one up a little bit so you can see the scale bar. scale bar, if you can see down there, it is 20 nanometer. 20 nanometer, it means that we are decreasing the size. The previous scale bar was 20 micrometer. Now we are decreasing. Looks like we are looking inside one single grain. So this grain itself, it consists of some atoms. So we are going inside. We are considering more deeply at the nanoscale. Inside, looks like we are looking just to one single grain inside this material microstructure. So this is a material microstructure. Now we're gonna zoom inside one single grain to reach to the nanostructure. Make sense? So it is a lower scale. It is here 20 nanometer. If you can observe here, the scale is 20 nanometer as well, or 200 nanometer, I'm sorry. So for example, this is one form of a nanostructure of a material. This is another form or two different forms of nanostructure of the material. As you can see, for example, in this case, these small blocks it would be in the micro scale. So we're going to say that this is microstructure, or this block, this thing represent a microstructure of the material. But next to this microstructure, there is a nanostructure. This is nanoscale. Because if you just measure the size of this small particle down here, this is going to be in the nanoscale. So we're going to say, as written here, it is e.g. nanoparticle, right? We do have here another nanoscale particle. We do have here some nanoscale, but so this is like a hybrid microstructure, or a hybrid structure of the material that include microscopic things or microscopic particles. Plus, in addition, we do have nanoparticles in the meanwhile. As you can see, this is like kind of atomic structure, but as you can see very clearly, if we try to zoom in, okay, let me zoom in a little bit, this one here. So as you can see, these are like small atoms, these small circle, these atoms represent atoms, and these atoms are arranged over one single plane. If you can just observe this one single atom here, this line of atom, this is like one plane of atoms. The number of atoms here, it is huge actually, and we do have another plane of atoms. So these atoms, they do have a certain arrangement. This arrangement of the atom is known as the structure, atomic structure, or the structure and how these atoms are arranged inside the material. So this group of atom represent like one single grain, and this group of atom represent another single grain. And there is this, because as you can see, you can identify like a line or a boundary that distinguish one grain from the other one, depending on what? Depending on the changes in the atomic arrangement. So for example, these atoms over this part, they do have a certain arrangement, but this atom, they do have a different arrangement. So we can set up a boundary between them. You got my point? So all of these things will be discussed with more detail as we move on through this course. But what I'd like to demonstrate here through this figure is that everything is related to the material structure. Like this atomic structure, it do impact the mechanical properties. If we did changes to any one of these structures, whatever the nanostructure, the atomic structure, the microstructure of the material, we are going to change the properties of this material. And again, this is the concern of material science, is to know the relation between the structure and the material properties. Another level of the material structure is the atomic structure. The atomic structure, like this case, that's like these two figures. Here we are decreasing more. We are decreasing to the nanoscale, 5 nanometer. This one, even it is just 1 nanometer. It is very tiny thing. So all of these images, we got them through through the TM, which is transmission electron microscope. And this is like a huge machine that's used for getting images of the material atomic structure or microstructure or nanostructure even. So the atomic structure, that the material will be seen like a colony of atoms, like set of atoms, group of atoms, and these atoms are arranged in a certain manner, in a certain way to form a material. The atomic structure deals with the atoms of the material and how they are arranged. The key idea, how you arrange these atoms to form a molecule or a crystal or a grain. The crystal or the grain is the same concept. Like we are going, as I explained over this image here, like this group of atoms here, as you can see, for example, we can draw like a virtual line. You're gonna feel that there is kind of virtual line that make this set of atoms, they do have a certain arrangement which is totally different than this set of atoms here. Like the arrangement will be different of this group, different than this one. So we could say that this is crystal, this is another crystal, or this is grain and this is another grain. Make sense? So this is the atomic structure, like that the material will be seen like colony of atoms. If we zoom in into this figure, this is here we are talking about 1 nanometer scale. 1 nanometer, it means that it is very tiny thing, very small thing inside the material microstructure. So you can clearly see the atoms. And as I said, this is like one plane of atom, and this is another plane of atom. So as you can see in this way, do you see this white line? This white line distinguish, this is like a virtual edge, virtual boundary. This is the physical meaning of grain boundary. This is a virtual boundary that distinguish this group of atoms from this group of atoms. Atoms here, their atoms are arranged over certain planes, and these planes are oriented in this way. So this is like atomic orientation, are oriented in this direction. But if you're gonna look to this atom, these atoms, their plane is oriented differently, right? So we can set up a virtual boundary that distinguish not atoms. Here we are not distinguish the atom. The atom are the same. This atom here is typically the same atom there, but the arrangement of atoms here is different than there. This arrangement is known how you build the structure, the arrangement of the atom. This is the physical meaning of a structure. So the structure, the atomic structure here is different than there, so that's why there is a boundary between them. The changes in the structure, the atomic structure, it do affect the mechanical properties. If the atoms over this side and the atoms over this side, they do have the same arrangement, it means that there is no boundary between them. This material will be with a certain properties. But if there is a boundary between them and the orientation, it means that these atoms oriented differently than this atom, this will give a different mechanical properties. Even these properties will be dependent on this angle, how much it is. As we increase the difference between the two orientation, we are going to enhance the strength of the material. So these relations between the material structure and these different forms of the material structure and how they do affect the mechanical and electrical and chemical properties, this is the main concern of this subject of the material science. Make sense? So that's why we are discussing here the different forms and different types of the material structure, like in this case. For example, in this figure here, this is also 5 nanometer. This is atomic structure of the material, and we are looking deeply inside the material. These arrows indicate like delamination between the different layers of the atoms. Like in this case, we have here like this line is like straight line, but here it is like corrugated line. This indicates that there is one plane and there is another plane next to it. It has been delaminated or slided with respect to the other one, right? So this resulted in this corrugated plane of atom. This is one type of the material defect. This is a defect. This is another defect. The grain boundary is a defect. The misorientation, the difference in the orientation, it is one type of the defect. All of these different forms of the material defects that we can see them by the microscope inside the material structure, they do affect the mechanical properties of the material. And again, the objective is just to understand the relation between these different defects and how they do affect the mechanical properties of the material. This is what we are going to discuss through this course. Make sense? So, in general, as a material structure, we do have 4 levels of the material structure. We do have microstructure. This is how we are going to see the material in general. We do have microstructure, we do have nanostructure, and atomic structure of the material. These are different levels. The microstructure, if we're gonna look the material in the millimeter, the meter, the centimeter scale, but microstructure, we have to look at it through the microscope to the micro scale. So we're gonna see things, other things. If we're gonna look at it through TM, more deeply inside the material with lower scale, we're gonna see other things. We're gonna see the nanostructure of the material. If we zoom in more, we're gonna see the atomic structure of the material. These are different levels of the material structure that definitely we are going to consider through this course, and how they impact the mechanical properties of the material. So the atomic structure, for example, most of the electrical, magnetic, chemical properties arise or strongly depend or came originally from the atomic structure of the material. So that's why one of the things that we are going to discuss as well through this course is the atomic structure of the material and how it would affect the different properties of material. So again, the concern of the subject is to find a relation between and understand the relation between these material structure, these different levels of the material structure, and their mechanical different properties, especially the mechanical properties. Make sense? So that's it for this video. And again, just very quick summary of the thing that we already covered here. We discussed the difference between material science and materials engineering. Then we discussed the different disciplines and the different subjects of the material science. We discussed what does it mean, material processing, material structure and the different types, material properties, performance. Then we discussed with some details, the different types and levels of the material structure. Starting the next meeting, we're gonna discuss the classification and the different types of materials and their different properties, and we're gonna end up with the different finish this chapter with discussion on the advanced material like nanomaterials and the metamaterial. Make sense? So that's it for this video, and thank you, and see you in the next lecture for another video. Thank you.